Now we're going to actually talk about what acceleration is more deeply. Okay, many of you so far have probably got the intuition that acceleration is just a change in velocity, and that's true. But to be a little bit more specific, acceleration is the rate at which velocity changes. Okay, if acceleration is 0, an object's motion remains constant. It doesn't change. Okay. In order for an object's motion to change, you need an acceleration. That doesn't mean an object's motion is 0, but if there's 0 acceleration, an object will just go on and on and on and on at the same velocity forever, okay? And so how do you capture the rate at which an object's velocity changes? Well, it's pretty simple. You just say that acceleration is the change in velocity divided by how much time it took for that object's velocity to change, okay? So the acceleration that an object undergoes between 2 points is the final velocity minus the initial velocity divided by the final time minus the initial time. Sometimes this is just reduced to delta V over delta T, okay? Simple as that. So this is the wait, but what is acceleration actually slide. And if you just advance one more, you'll see a slide called airbags, okay? And one of the neatest examples of this, and something that's definitely relevant to you guys as people who will be healing people, is this whole idea of airbags, okay? The whole reason why an airbag works is because you increase this time here with an airbag, and so if I increase that time interval, then my acceleration goes down, right? Okay, and some of you guys may also know this little equation called F equals ma. So the force that any object experiences is equal to its mass times its acceleration. So if my acceleration goes down, that also means that the force that I experience on my head trauma, must also go down. Okay, so let's look at this a little bit more specifically. This question says, the human body can survive an acceleration trauma incident if the magnitude of the acceleration is less than 250, so less than 250 meters per second squared, okay? And I want to talk a little bit more about this meters per second squared. What does that mean? It really means meters per second, okay? In other words, if I'm experiencing an acceleration, or in this case, deceleration, of 250 meters per second squared, that means that every second, my velocity changes 250 meters per second, okay? But obviously, if you just make things more simple, that second goes down to the bottom and you get second squared. But this ultimately means that every second I'm undergoing that acceleration, my velocity is changing by 250 meters per second, okay? So if I'll just use myself as the crash test dummy in this example. If I'm in an automobile accident with an initial speed of 105, so in other words, V1 is equal to 105 kilometers per hour, or 65 miles per hour. So this is 105 kilometers per hour, right? And obviously if I come to rest, my V2 would be what? 0. So I'm in an accident, I come to rest, so my final velocity will just be 0, okay? So if I go from 105 kilometers per hour to 0 kilometers per hour, what is the minimum time needed for my body to come to rest so that my acceleration does not exceed this 250 meters per second squared, which will give me brain damage, okay? All right, you already know all the tools to answer this, so that if, I don't know, Honda came to you and was like, hey, I need to find out how to design my airbags, you could tell them you need an airbag that has a compression time of at least this many seconds. So let's see what that'll be. First things first, I contacted Siri before this lecture and had her translate that for me. That is actually about 29 meters per second. Actually 29.2. Okay, and this is obviously 0 meters per second. Okay, so here's the thing. My acceleration is going to be v2 minus v1. v2 is 0, right? That's my final velocity. I've come to rest. My initial velocity was 29.2 meters per second. Okay. My time interval, t2 minus t1, I'm just going to call it t. That's my whole time interval with which my head's decelerating, right? And I don't want this to exceed, I'm going to erase this bad boy here. I don't want this to exceed 250. Okay? I'll pause there, make sure everyone's cool, everyone's on the same page. Now, if I want to solve for the thing on the bottom, just a shortcut, I call it the switcheroo. You can just switch whatever's in the denominator or whichever here is in the quotient, okay? So t is going to actually be negative 29.2 meters per second. And to be totally clear, since this is a deceleration, since this object slowing down, this is going to be a negative 250. So I'm going to put negative 250 here, meters per second squared. Okay? That's going to give me a time of 0.11 seconds. Okay? So I'll just refresh what I did here. I said that I used this equation and said that I do not want an acceleration of more than 250 if I'm going from a speed of 29.2 meters per second to 0. Okay, makes sense? And I want to solve for the time required, the minimum time I need, so that this change in velocity will result in this acceleration. So this tells me then that I want to design this airbag so that the time it takes for my head to come to rest has to be more than 0.11 seconds. This gives you a baseline. Obviously, if you're really designing this airbag, you'd want this airbag to have, you know, maybe 0.15 or as much as 0.2 seconds so that you can be sure that it'll be a comfortable collision, if that's even possible. Okay, all right. The next slide, if you look, it is a jet fighter blackout video. So this, one way to measure acceleration is in G's. So 1 G of acceleration is actually 9.8 meters per second squared. So we are always experiencing 1 G. Like if we just fall from, you know, an airplane, we're experiencing 1 G. So we typically black out at about 5 G. And people who are going to be like fighter pilots in jets, they have to be able to be comfortable with that 5G because they have several $1 billion of equipment that they're flying and their life's on the line. So the question is, what kind of physiological things can you do to stay conscious there? And there are some things like some squeezing and bearing down that you can do. And there's this video of these guys trying to do it, and it is hilarious. Very, very funny. So the video is there for you to see. But in the meantime, I will take a look at this problem that we have here. And I will erase all this.